Hey everybody. Tonight we are going to take a little break from inequalities and compound inequalities to do some work with absolute value. Now, the inequality stuff is going to come back in eventually. You're going to see how this all ties together. But for right now, we're going to start introducing a couple of new things. Now, some of you have probably heard about absolute value before. Absolute value basically just tells us the distance between a number and 0 on the number line. So if we have a number line and we have positive 7 over here, and we have negative 7 over here. And I want to know what's the absolute value of 7 and negative 7. And we show absolute value like this. We use two little bars, and we put the number inside. So the absolute value of negative 7 is equal to the distance, the number of units that negative 7 is away from 0. Negative 7 is just 7 units away from 0. Positive 7 is also 7 units away from 0. Because absolute value just tells us to count the number of units, the absolute value is always positive. Okay, this is very important to understand, and people often make the mistake of thinking that they just change the sign of the number. The absolute value of positive 5, they think that it should be negative 5 because you could change the sign, but that's not true. It's always going to be positive. The absolute value of 5 is always 5. But so is the absolute value of negative 5. And that's really important for doing the types of complex problems that we're going to see in a second. When it gets tricky is when we have to work out problems that involve absolute value, because there can be a lot of steps, and we want to make sure that we don't actually use the absolute value at the wrong time. When we're doing the order of operations, we always treat the absolute value as if it is a grouping symbol or parentheses. So when we're doing PEMDAS, our absolute values come at the very beginning. Okay? Now, we don't calculate the absolute value right away. First, we actually have to know what is the value of the number inside the absolute value. So for our first example here, we have 3 times the absolute value of negative 7. Now, I know that inside this absolute value, this is the only number in there, negative 7. There's no steps to do in there. So I can take the absolute value of negative 7, which is positive 7. So this becomes 3 times 7. 3 times 7 is 21. There's our answer. Okay, that one's pretty straightforward, but when we have stuff like this next one where we have things inside the absolute value, it gets a little trickier. Since we treat the absolute value like parentheses, we calculate everything inside the absolute value first. 2 minus 6 is negative 4. So this becomes 5 minus the absolute value of negative 4. A big mistake people want to make is they want to just make everything positive right away. They want to change this negative sign or this minus sign to a plus. But that's going to give us a completely different answer. We calculate what's in here first. 2 minus 6 is negative 4. Once we know the value of the expression inside the absolute value, that's when we make it positive. This becomes 5 minus the absolute value of negative 4 is positive 4. 5 minus 4 is 1. Okay? These next two, they look a little complicated, but if we follow the order of operations, it's not going to be that difficult. In our numerator here, in our first one, we have the absolute value of 5 times negative 2 times negative 1. Again, we're going to calculate what is in here first. 5 times negative 2 times negative 1. 5 times negative 2 is negative 10. Negative 10 times negative 1 is positive 10. We have the absolute value of 10 over 10. The absolute value of 10 in the numerator is just 10. So you've got 10 over 10, which we know equals 1. In our fourth example here, same thing. We're going to calculate what's inside the absolute value. Negative 3 minus 4, that's negative 7. So we have the absolute value of negative 7 plus, and we can calculate what's over here, 2 times 3 is 6. Now, because we have our absolute values with just numbers inside them, we can take those. -7, the absolute value is +7. The absolute value of 6 is 6. 7 plus 6 is 13, right? Not too bad. All right, we're going to finish up with two more complicated ones, and then we'll be done. In our first one, we have 10 minus 3 times the absolute value of -2 minus 4. So first thing we got to do is calculate what we have in here. That's going to give us -6. We have 10 minus 3 times the absolute value of -6. Now when we take that absolute value, that's going to become +6. 10 minus 3 times 6. Now we can think about that as -3 times 6. That'll give us -18 or -18. And 10 minus 18 is -8. Now, just because there's an absolute value in the problem doesn't necessarily mean the answer is going to be positive, right? The absolute value is just going to make this number positive right here. That's all it's going to be used for in this particular problem. In our final example, 8 plus 3 times the absolute value of -2 times 6 plus 4. So we can start using the order of operations here. We can calculate what's inside. -2 times 6 is -12 plus 4. Because we haven't calculated the absolute value yet, we're going to leave everything inside the way it is. I'm not changing that -12 positive yet. I'm not doing anything until I have that inside piece completely calculated out. Now -12 plus 4 is -8. Now that I have just the number inside, here's where I can take the absolute value. 8 plus 3 times +8. 3 times 8 is 24, and 8 plus 24 is 32. So that's how we do the order of operations with absolute values. A key to doing these is making sure you show every step. You show your steps, you take your time, you're much more likely to get the questions right than if you rush, you try to do everything in your head. Okay? Go ahead, finish up your notes. Don't forget to submit through Canvas, and I will see you all tomorrow.